Hello, let's do some chemistry. Okay, do you remember? Bonds between atoms in the reactants are arranged to form new compounds, and none can disappear and none can magically appear. So we have to learn how to balance equations. Next. Therefore, you have to balance the equation. We did this in lab, and you should have become fairly familiar with it. We'll do some more problems next week, and we'll do some more in lab again. But it will behoove you to learn how to do this. You're really just going to take and say, look, there's one carbon here, there's one carbon here, there's 4 hydrogens here, let's add a 4. Let's see what happens. A lot of it is just trial and error. When I do it, I'm like, oh, let's put a 4 here and see what happens. Oh, look, now I have 4 chlorines. Oh, look, now I have 8 chlorines over here, and I can manipulate that until it works. Do you see how we did all of that good stuff? Oh, here's a chlorine. Does everyone see that? So it's just really a matter of, hold on, my screen's not working. Okay, so you need to learn how to do this. Coefficients multiply everything. So this 2 is going to multiply the hydrogen, and you're going to have 4 hydrogens and 2 oxygens. It's almost like there's an imaginary parentheses around this. You can't add subscripts. You can only add coefficients when you're balancing equations. Okay. Now we need to talk about equations because we also need to talk about what types of equations they are. Substances that take part in chemical reactions may be solids, liquids, gases, or dissolved. This information is added to the equation by placing symbols in the formula. Solid, liquid, gas, aqueous, in dissolved solution. Does everyone have? Yes. Okay. Now, moving along. So we're going to write an unbalanced equation using the correct formulas for all the reactants. We already know how to do that. Then you're going to, where is step 2, step 3, check the equation to make sure it works. This is the part where people miss. They add things and they think it's right, and they don't go back and start over and say, okay, let's make our list again and make sure everything's equal. It usually just is a small mistake, but I'm just reminding you that this is important. Okay. We should know how to do this. We did it in the lab. We already talked about it. So we need to move on. There are 3 types of main reactions. Precipitation reactions are processes in which an insoluble solid forms a precipitate. A precipitate is something you can see. It's a floaty. You're like, there's a floaty in my water. That's a precipitate. It creates something. When the reactants are combined in aqueous solutions. You will know this automatically because it will be abundantly clear from what happens in the reaction. You will be able to see. Then a neutralization reaction is going to start with an acid and a base, and then it's going to make water and a salt. How are you going to know? Because it starts with an acid and a base, and it ends with water and salt. Sometimes there are other things, but it ends with water and salt. If you've got H2O and NaCl, it's always going to be an acid-base neutralization reaction, sometimes just called neutralization reactions. A neutralization reaction removes hydrogen ions and hydroxide ions from solution and yields neutral H2O. This is how you're going to know. We're going to do this in lab, so don't panic. I just want you to be familiar with it before we get there. Any ionic compound produced in an acid-base reaction is called a salt. So whatever this is over here is called a salt. Even if it's not NaCl, still called a salt, still we're going to consider it a salt. Okay? So don't panic. I don't know what salts are. It's okay. If it has water and it starts with an acid and a base, which I will tell you, it's an acid-base neutralization reaction. I swear this isn't going to be as hard as you think it is. These are oxidation reduction reactions, or redox reactions, are processes in which one or more electrons are transferred. So here's what we're doing. Remember, we have electrons. We know this. There's no reason to panic. So what we're doing in a redox reaction is we're following the electrons. Where do these electrons go? So we still have -4 over here. Now we have +4 over here. We've got this moved over here. This oxygen moved over here. Oxidative reduction reactions are processes in which one or more electrons are transferred. So we're transferring electrons. This is how you know you have an oxidation reaction. We will do these in class. We will do some problems. Again, we've got a -4 over here, and all of a sudden it became a +4. it gave some away. It took some here and it gave some here. Okay? Carbon does that. It's crazy like that. Sometimes it takes things, sometimes it doesn't. Don't worry. These are not as hard as you think. We will work on them. There will be problems. Don't panic. Do not panic. Okay, as a result of this transfer, the number of electrons assigned to individual atoms changes. So again, we have the same. We've balanced the equation, but we still have carbon here now is with carbon here. How do you know that? One of the ways you know that is because oxygen is always going to be negative. It's always going to take things. No option. It's a bully. It's taking things all the time. Carbon can go either way. It's got 4. It can give 4. It's like, I don't really care. Not so much with oxygen. Oxygen is a bully all the time. It's going to take it. So over here it was with hydrogen, who is willing to give the electrons to carbon. Then it moved over here and partnered with oxygen. And oxygen has a negative charge. And so that's how you know your carbon moved. These, you've got to just do them. It's one of those things where we're going to do lots and lots of them in class. We're going to do lots of them in lab until you are like, I love redox reactions. Don't worry. Reactions involving covalent compounds are redox reactions since electrons are rearranged as bonds are broken and new bonds are formed. So you will get comfortable with this. You will know exactly how to do it. See, do you remember? This should look very familiar. You already know where carbon is. You know it has 4 in its outer shell. So sometimes the question is just, is it negative or positive? Hydrogen is usually going to be, it can go either way too. Hydrogen can sometimes be positive. Oxygen is 0 right here. It doesn't have a charge. Carbon went from -4 to +4 because oxygen needed to take something. Hydrogen went positive. Oxygen still negative. It's just, we're looking at the periodic table. We're figuring it out, and it's going to be fun. You can predict if you will get a precipitation reaction based on solubility. So insoluble precipitates, group 7 are soluble. I will give you this table if I ask you these questions on the test. So don't panic. No one's panicking. Okay. Whether a precipitation reaction will occur in a mixed aqueous solution of 2 ionic compounds depends on the solubilities of the potential products. Okay? How soluble they are will determine whether or not they do, in fact, precipitate out. There you go. What is solubility, you ask? You need to write it down. Solubility is the amount of a compound that will dissolve in a given amount of solvent at a given temperature. So how much sugar will dissolve in your tea at a given temperature? At room temperature, it's less. At room temperature, less sugar will dissolve in your lemonade or sweet tea or coffee or whatever you drink. At a higher temperature, it's going to dissolve much quicker. So solubility is the measure of a compound that will dissolve in a given amount of solvent at a given temperature. The temperature is important because if you raise the temperature, you're going to get a higher solubility. Your sugar is going to dissolve much better. This is the whole concept of sweet tea. If a substance has a low solubility, then it will likely precipitate. It will likely just still be a floaty from an aqueous solution. If a substance has a high solubility, then no precipitate will form, and it will just dissolve into a sugary awesome solution, or a solution where you can't see any floaties precipitated there. General rules of solubility. A compound is probably soluble if it contains one of the following cations. Group 1, lithium, sodium, potassium, yes, or ammonium cation.